Hey, math friends. So our learning target today is that I can calculate the slope by using the formula. So what we're going to talk about today is what happens when we don't have a graph and we can't run, we can't draw a rectangle and calculate the change that's happening in the data without the picture. So that does happen to us sometimes. So we kind of need a plan B when that occurs. So we're going to do something called the slope formula, and that's given the 2 points on the graph. So the idea of if you had 2 points on a graph, how would you calculate the slope if you didn't have the picture? All right, so same information as before. We still are going to have these 2 data points, and they're going to be listed as x, y. There will be 2 of those, just like we did before. We'd identify them and draw a rectangle. The order is super important. That's good to know. That xy is very, very different than yx. So you can't just flip them because it works better for you, because that means it's in a different location. Subscripts, sub meaning below, are used to distinguish between the ordered pairs, such as x1, y1 is different than x number 2, y number 2. Now this is not an exponent. You'll notice it's sub, meaning it's below. It's just a description. That basically is x number 1, y number 1, x number 2, y number 2. So that is kind of the plan for today, is that we are going to find the slope without the graph. So we're going to use this thing called the formula. So the formula states in the middle here that in order to get the slope, we find the change in the y. By the way, this little triangle here in math means change over the change in the x. So we're still calculating rise over run, just like we were before. The dilemma is we just don't have a picture. So we're really talking about our up and down movement and our left and right movement. So the deal basically is that we just have to be able to subtract our y's and subtract our x's and be able to calculate that. So this is the formula. The easiest way is to stack them in a table and subtract. So we could plug it into this formula, but I'm going to jump right to what I believe is the easiest way. So if we set these up into a table, you know they're in alphabetical order. And in the table, then it doesn't really matter which one's first and which one's second. So let's plug them in, -2, 1. And we have 4, -1. So subtraction is the operation here, because we're finding the change in the y. Now the key is that you have to do the y's first. So when you make your table, I'm going to ask that you draw the line down, and then I'm going to ask that you set it up just like this so that you make sure that you get this nice stacked slope. Just like this, down to the right. So the change in the y's would be y minus y. Now be careful on that. You can use your calculator, but that essentially is saying 1 minus -1. And I'll say, no, we're not going to allow that to happen, because that really means opposite. So this becomes 1 plus 1, which is 2. So my rise is 2. My run, then, we subtract. So that's -2, and -4 is -6. So this reduces to 2 over -6, which is equal to, now in math, I like to have the negative on top. So we're going to divide the top by 2 and the bottom by 2. So if we take half of the top, that's 1. We take half of the bottom, that's 3. So the slope of that line would be -1/3, using just the formula. Just the formula, still doing rise over run. But that's how we do it when we don't have a picture. So if that was really like, whoa, what just happened? You need to rewind the video right now and just watch that again. We will do probably about 6 examples of this throughout the course of the hour. So your other option is to just stick with the video and see as we go through example 2, 3, 4, and so on, does the understanding get better? All right. So using the slope formula, I'm going to stack them instead. So here's my x and here's my y, here's my x and here's my y. And the way that I teach it is it doesn't matter which one's first and second. So that's what I like about that. So we end up with negative 5, 7. And we end up with negative 1, negative 2. And we're going to subtract. So we're going to subtract our y's first because the y's have to go on top. That's the key. The y's has to go on top. So 7 minus negative 2. When we're minusing a negative, we really get positive 9. And negative 5 and negative 1 is negative 6. That equals a negative in that problem is there's one negative in here is going to result in a negative. I'm going to pull it to the top. And we're able to divide the top by 3 and the bottom by 3 because they both have factors of 3, which becomes negative 3. Where did I get that negative? I pulled it from the bottom. It's not wrong to be in the bottom. I just don't prefer it. And then I'm going to divide the bottom, that's 6 by 3, which is 2. So my slope of this line is negative 3 over 2. Again, if you want to keep watching and going through the next examples, that's awesome. Otherwise, you can rewind the video and watch those two again if you're like, I'm just struggling here. Super important skill, just like before when we talked about that. It's just a little different in that we don't have the picture. Still kind of working the same idea. All right. So in our table then, so we set up our table. And we're going to make our fraction down here. So in our table, we have negative 5, 7, and negative 1, negative 2. And we're going to subtract. We do our y's first. So we have 7 minus negative 2 is 9. That's the exact same problem we just did. Yep. All right, we're going to just keep solving it anyway like we didn't see it before. And negative 5 and negative 1 is negative 6. That reduces to negative. Divide, divide. 3 is a common factor there. I'm going to pull the negative to the numerator, becomes negative 3 over 2. So the slope of that line is negative 3 over 2. Next problem. All right, let's set it up in our table. So we have our x, we have our y, and we're going to make our fraction down here. So in our table, we have 2, negative 6, and we have 9, negative 9, negative 6. Set it up, set it up. We subtract the y's first because that's the change in the y. Negative 6 minus negative 6 becomes 0. You can type that in your calculator if you're not quite sure how I got that. Subtract over here. 2 minus negative 9, that becomes positive, is 11. And what is the slope of this line then? 0. Because 0 divided by anything is 0. Again, pause the video at any time if you're struggling with the slope formula. All right, group, next problem. How do we find the slope when we don't have a picture? Here we go. So we have 7, 8. We have 7, 2. Subtraction of the y's, subtraction of the x's. So we end up with 8 minus 2 is 6. 7 minus 7 is 0. And what is 6 divided by 0? 6 divided by 0. Type that in your calculator once. Type 6 divided by 0 in. Type it, type it, type it. And you should see error. So what the calculator is saying is, whoa, what's going on there? That doesn't seem safe. What they're saying is that that is a vertical line with an undefined slope. So the slope of this problem here is actually undefined because you cannot ever divide by a 0 on the bottom. Vertical line. All right, group, hang in there. So last problem on this page of how do we calculate slope when we don't have a picture of the graph. So here's my xy. I'm going to set up my fraction down here. All right, let's plug in our data points. We have negative 2, 4, and we have 0, 0. Having a hard time getting the pen to work here. Hopefully it works now. All right. So this is supposed to be a 0. As we subtract then, we're going to subtract down. So 4 minus, this is 0. 4 minus 0 is 4. This is a 0. Negative 2 minus 0 is negative 2. So what's the slope of that? 4 divided by negative 2 is really a triangle problem, results in a slope of negative 2. Again, this is super important, so go back if you're not quite understanding how to do the work. The next slide, what I'm going to do is prove to you that we get the same answer, rise and run, or the formula. So on the left side, I'm going to take our old skill of rise over run when we're given a picture, and then I'm going to prove it to you on the right if we take the picture away and use the same data points that it's the same answer. So let's go back to rise run here. Why don't you pause the video, get the rise run slope of that problem on the left. So Slope Man says, of course, that this is a negative slope because the line is decreasing. So you should have said negative. Here's my data point, drive it down, turn the corner, drive it up, turn the corner. So we end up with 1, 2, 3, 4 over 1, 2. So my slope of this line is negative 2 or negative 2 over 1. So we'd be saying like we're losing 2 gallons of gas per hour, or we're losing $2 per week or something like that. Okay, so on the right-hand side, what I'm going to do is I'm going to take these two data points off the graph, and I'm going to prove to you that using the formula, we get the same answer. So those are the two data points that I need to use. So we're going to set up this table. I'm going to make my fraction bar down here. All right. So we have negative 2, 3, and we have 0, negative 1. We're subtracting then as we solve. So this becomes 3 minus negative 1 becomes really a positive 4. And you can put that in your calculator if that's confusing to you, but that's that chop chop idea. Negative 2 minus 0 is negative 2. Now notice here, the negative's in the bottom this time versus over here the negative is on the top. But it still results in a slope of negative 2. So it doesn't matter whether we use the graph. We got a slope of negative 2 using the graph. Or if we use the data points, it's still, we get a slope of negative 2. So that's what happens when we lose the graph. How do we calculate slope? We set it up in this table. We subtract the y's, and we put them on top of subtracting the x's. All right, last two problems of the day. So why would we use the formula? Well, sometimes graphs aren't there, and sometimes graphs are simply just yucky. Like looking at this graph. Here's a data point, there's a data point. It's gross. Like we're starting at 28 and we're going up to 56. Not super easy to calculate at all. So this would be an appropriate time where it'd be easier probably to use the formula to figure out the slope of these two lines versus using rise run. Now you could use rise run, but those are really not super comfortable numbers. So I'm going to use the formula for both of those. So the first one is, what is the slope of your friend's line? Your friend's line is the blue line. So let's maybe do, so this is your friend's line. And this is your line. Maybe we'll just go right to this question right away, is which line is steeper? And you should be saying, well, which one is growing at a faster rate? Well, the friend's line is steeper. And let's look at let's analyze the problem. The friend has a steeper line. What it's saying in the problem is this, is that it's the amount of dollars earned babysitting per hour. So if your friend's line is steeper, that means that your friend is making more money per hour than you are. The friend makes more because the friend's line is steeper. So let's go analyze and actually see how much more money does your friend make. Okay, so your friend's line, if we put your friend's data into our little handy dandy table here, because I'm not going to rise run it, your friend has a data point of 428. I'm going to run out of space here, you guys. So I'm going to actually erase all of this on the bottom and start over on the bottom. Sorry about that. I'm just not going to have enough space. So your friend's line down here. So if we set that up, your friend has a data point of 428 and 856. 428 and 856 is the steepness of your friend's line. So if we were to subtract the y's, we end up with negative 28. Don't worry about the negative. And if we subtract the x's, we end up with negative 4. So negative 28 over negative 4. So your friend makes $7 per hour babysitting. And we've already said that the friend's line is steeper, which means that your friend, if your friend makes $7 per hour, then you make less than $7 per hour. So let's see what happens with you. So I'm going to use blue for a different color there. You. Will you make data points of 420? That means in 4 hours you made $20. And 840. So in 8 hours you made $40. And maybe some of you already see what that means. So if we were to subtract our y's and subtract our x's, use a brighter color there so we can see, you would get negative 20 over negative 4, which means that you make $5 per hour. So who makes more money? Your friend. Their line was steeper. How much more? Your friend makes $2 per hour more than you. So your friend's slope is steeper by $2 per hour. So that's another example of what we would do when we don't have a very nice graph to work with. The rise and run up here would have been really tricky because you would have had to rise and kind of estimate. You could have done it, but just not super nice numbers to deal with at 28 and 56. So that's when we'd use the formula. So to summary for our lesson today is that slope is measured by rise over run always. Now when there's a graph, it's no big deal. We just build our rectangle and we get it. But when the graph doesn't exist, then we have to use this formula y2 minus y1 over x2 minus x1, which is the change in y over the change in x. I did that. I just did it in a table form. I just did it in a table form because it's all set up for you. And then I created my fraction down here. So for example, if this was 2, 4 and 6, 1, then I would just simply subtract my y's, which that's what it's telling me to do, and subtract my x's, which that's what it's telling me to do. And that gives me the slope of negative 3/4. I do not like negatives in the bottom left alone, but that's the same idea of what we're doing today. That's your summary for today's lesson on I can calculate the slope using a formula when you don't have a graph. Have a glorious night.